Hello everyone, and welcome to today's broadcast. Today's date is June 27th, 2026, and it is a beautiful Saturday. I hope you're all having a fantastic weekend so far. I'm your host, Sano Anani, and I am super excited to be here with you today. Today, I will be introducing a trending article from the archive, and it is a really fascinating one about the future of video streaming. The title of the paper is An Evaluation of Average Switching for Time-Shifted Clients in MoQ. The pool is Tax Spargarxiv, or Yovibe 606.26,368 fun. It is quite a long title. But do not worry. I'm going to break it down and explain everything in a super fun and easy way. So let us dive right into it. Have you ever been watching a live stream of your favorite gamer, or maybe a huge concert, and suddenly the video freezes and you see that dreaded loading circle? That is right. We all hate rebuffering. When a lot of people are trying to watch the same live event, it puts a huge burden on the internet network. Currently, most video streaming uses something called adaptive streaming, which people usually refer to as dash or churls. These technologies are everywhere. But they have a big problem with high latency. Latency is just a fancy word for delay. So to fix this delay, engineers made low latency versions, but they are still limited because they relied on a pull-based system. That means your computer has to constantly ask the server for the next little piece of video, which takes time and slows things down. To solve this big limitation, the Internet Engineering Task Force is developing a brand new technology called Media Over QUIC Transport, or MoQ for short. This new MoQ technology uses a push-based system instead. It is like instead of you going to the store to buy a magazine every single day, the publisher just throws the magazine right onto your doorstep the second it is printed. It is incredibly fast, and it uses something called CUP to achieve ultra-low latency. But here's the catch, and this is the exact problem this paper is trying to solve. MoQ is amazing for keeping you right on the live edge of a broadcast. Its default way of switching video quality can actually cause those annoying playback gaps, especially if your internet connection gets a little bit unstable. Usually if your internet slows down, the Adaptive Bitrate, however, steps in to lower the video quality so the video does not stop playing. But in the current MoQ setup, when it switches the video quality to keep up with the live edge, it can cause massive bandwidth spikes and make your video stall. The researchers noticed that not everyone needs to be exactly perfectly on the live second. Sometimes, you might not mind being just a few seconds behind the live broadcast, if it means your video will not freeze. This is called time-shifted playback. The researchers found that this area is actually really understudied. So, they introduced an extension called time-shift-aware switch. To fix this whole mess, they separated the process of choosing the video quality from the timeline synchronization, and wow, the results they got are absolutely mind-blowing. That is right. They proved that by adding less than 4 seconds of stream delay, viewer can actually increase their overall throughput by 4 times. 4 times the data means way better video quality, just by accepting a tiny 4-second delay. Your video player basically buzz up a little safety net, called a cache, so if the network suddenly drops, the video just keeps playing smoothly from the safety net. Let us compare this with other technologies. Traditional type streaming is like sending a letter back and forth, asking for video chunks, which is safe but very slow. Then we have Rebuffering, which is what you use for video calls. Rebuffering is super fast, but it is rigidly designed for teleconferencing, meaning it does not scale well when millions of people are watching a broadcast. MoQ sits right in the sweet spot, combining the blazing fast speed of Rebuffering with the massive scale of traditional streaming. And with this new time-shifted Abra approach, online becomes incredibly flexible. Now let us talk about how this amazing technology applies to everyday life. I have thought of 3 really cool specific application examples based on the concepts in this paper. First, let us think about live sports broadcasting. Imagine you are watching the World Cup finals on your tablet while riding the train. Your internet connection on a train goes up and down constantly. If you use the standard ultra-low latency mode, your stream is going to freeze every time it goes through a tunnel, just to keep you exactly on the live edge. But with this new time-shifted mode technology, your streaming app can automatically decide to stay 10 seconds behind the live feed because of that 10-second safety net. The app can seamlessly switch between high and low video quality without ever freezing the game. You get to watch the winning goal in standing high definition without any loading circles ruining the moment. Second, this technology is a total game changer for live content moderation. Platforms that host millions of live streamers need to make sure nobody is showing inappropriate content. To do this, they use artificial intelligence systems to analyze the video frames. If the AI tries to analyze a stream with 0 delay, it might struggle to process everything in time, especially if the network fluctuates. But by applying the time-shifted Abra method from this paper, the moderation servers can intentionally sit 5 to 10 seconds behind the live edge. This allows the server to receive a much higher quality video stream, meaning the AI gets a clearer, crisper image to analyze. This leads to much more accurate content filtering, keeping the platform safer for everyone. And it does all this without causing the servers to crash from network spikes. Third, think about online education and massive lab tutorials. Let us say you're taking a live masterclass on digital art, where the teacher is sharing their highly detailed screen. In a learn environment, the exact millisecond of latency does not matter as much as the clarity of the image. If the teacher writes a tiny mathematical formula or draws a fine line, you need to see it perfectly. Using this time-shifted MIME setup, the educational platform can prioritize maximum throughput over strict 0 latency. Students might hear the teacher 3 seconds after they actually speak, and in exchange, they receive a rock-solid, high-bitrate stream. The video quality stays crystal clear, even if the student is watching from a cafe with spotty Wi-Fi. This makes remote learning so much more accessible and frustration-free. It is just so cool how a tiny change in how we handle video data can make such a massive difference in our daily internet experience. The researchers even built a simulated network environment using a tool called Mainnet. To test all these different network profiles like stable, step, and sinusoidal waves, they proved that when a sudden drop in bandwidth happens, the time-shifted clients handle it gracefully, maintaining near maximum bit rates, while the strict live edge clients suffered from heavy rebuffering. Of course, the researchers also mentioned that there is still room for improvement. They named us that the time it takes to execute a quality switch is still a little bit higher than they want. The switch time should be less than or equal to the duration of a single group of pictures. But since this is still in the experimental phase, future software optimizations will easily add those little bumps. They are even looking forward to hybrid systems, where the network server actually talks to your video player and gives it advice on how to adjust its settings. Well, that is all for today's deep dive into the world of Media Over QUIC and Adaptive Bitrate streaming. I hope you found it as incredibly fascinating as I did. It is amazing to see how brilliant engineers are working hard behind the scenes to make sure we can all watch our favorite videos without any annoying interruptions. Thank you so much for tuning in to my broadcast today. I have been your host, Sano Ani, and I hope you have a wonderful rest of your Saturday. Stay bubbly, and I will catch you next time.